Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay guys, we have went through our notes up to this page, I believe. So we continue from here with okay. Okay, we have stop here regarding the starting of the three-phase induction motor. Okay, there are some normally control or practice in the field regarding how to protect our motor here, and the motor to be protected from the inrush current, So what happens that when we start our motor, there will be a inrush current, which will be multiple times of the rated current. If you plot your top speed of your motor, it will be like this. But if you plot your current and current versus speed, there will be a spike. Your I load will be very high during starting. So here, when you plot this top speed curve, by right, the rated speed, this is your synchronous speed. So here are your rated speed actually, and M. So maximum rated speed will be from here. So actually your rated torque is at this point, and 100% of your rated torque. Same goes to your current. So here at your synchronous speed, this is your motor speed, and so the rated current is here. This is your I rated and I rated. So the starting will consume very high starting current. So that's why we have to adjust, or we have to control in terms of when the motor wants to start, we have to modify in terms of incoming terminal voltage or other kind of starting adjustment to avoid this kind of inrush current that will tend to damage our motor. Okay, per the lab sheet that I provide to you all, here are the generic appearance of a normal induction three-phase motor. Okay, on the motor itself we have this box, terminal box, connection box. So if you take a look inside the box, you will have you can see the 6 terminal, and which we will connect to the source. Okay, the 6 terminal you can see like this: 1, 2, 3, 4, 5, 6. So normally this is being labeled as U1, and this is V1, W1. Meanwhile, here are U2, V2, and W2. Okay, but some motor, they are labeled as U1, V1, W1. Then here are the U2, V1, and U2, V2, and W2. Okay, what is the terminal underneath the connection? So this is the connection between the coils, the incoming source, then it goes into the coils underneath your inside your stator, then come up at U2, then V1, so it goes into the circuit and come up at V2. Same to the W1 here, it goes into the circuit, into the coil, and rise at W2. So normally we have delta and Y connection on the motor. So if you can see on the template, on the nameplate, and on the nameplate of the motor. Okay, on the nameplate of the motor, let's say this is the example of the nameplate. We have two values here, which is low voltage and high voltage. So the low voltage rating is applicable for the delta connection circuit. Meanwhile, this high voltage, which is 460, is applicable if you connect to the Y connected kind of connection to the motor. So it means that if you use a single phase connection between line to line, you can construct in terms of delta connection. But if you use a three phase connection, you can use this one, because you cannot apply a higher voltage to the delta type connection, because it will exceed the rating and it will damage your insulation and your motor. So it means that this delta is for low voltage and Y is for high voltage. So in terms of starting the induction motor, what we tend to do is that we set the motor at Y connection, but we put a low voltage first, such that the current that go into your circuit could be reduced, and we can have a reduced current that goes into the motor. Once it start, then we apply back the normal voltage or the high voltage. So we use the Y connection, but we apply low voltage, then high voltage. So that's why we have this kind of circuit, the star delta type. And we apply the low voltage, or we apply on the star type of connection the same voltage. So this is the same voltage, the coming incoming voltage here. We connect in terms of star connection. Star connection means that all the outputs here will be output of V2, U2, U2, V2 and W2 is interconnected. We put a metal plate to short all together. So this is the star connected connection type. So all of this will be connected, and the incoming here connect here, and then all the W2, V2, U2 are short together. So we construct a Y connection, but we apply the same voltage. Once the motor runs, so we disconnect here, and we disconnect this one, but we connect this one and this line. So it becomes delta. First we start with star, or Y connected, then we end with, or we continue with the normal delta connection. So we can have a low incoming current with the starting, then it continues with the normal current. Okay. Another kind of control, how to control the starting current, is that by reducing or introducing the resistance and impedance to your rotor circuit, to the circuit that goes into your motor. So it was stated inside your notes that another way to reduce the starting current is to insert the extra inductors or resistor. We have here extra inductor resistor here before on the power line of the circuit during starting. Then once it runs, so we just remove the resistor. We just continue with the normal lines, or we use auto transformer and starter to reduce the incoming voltage. So actually for induction motor, we have only two techniques. There are only two techniques to control the speed of the induction motor, because we have here SY and synchronous speed is equal to 120 F over P. So this is your frequency, and you have your motor. We have our motor here, and we have the incoming source. So it depends on the frequency of your source, and the speed, the synchronous speed, depend on the frequency, and also the number of poles. And you have such like 2 poles and 4 poles and etc. Maybe you have 8 poles and construction of your motor. So the higher the poles number, so the lower the speed, overall speed or synchronous speed will be. And the higher the poles, the lower the speed. The higher the frequency, the higher the speed. And so you can manipulate in terms of frequency, and also number of poles. So nowadays we have inverter, and so easily you can control the speed of the source, or we can modify the frequency of the source by using inverter. So we have here inverter. Another kind of control to modify the speed of your induction motor is by slip control, and either by control the, or we can monitor the, we can adjust the resistance of the rotor, like what we apply on the wound type rotor or wound type induction motor, or we adjust the terminal voltage of the motor, and the incoming terminal voltage we can adjust, and you have your source and before it goes to the motor. So you modify in terms of the magnitude of the source, and the lower the magnitude will be, the lower the top, and the lower the speed. So to review, there are only two kind of normally terms that we always discuss in our induction motor concept, which is slip or slip speed. And we have slip, which is minus and synchronous. So this is your slip, and how much the difference between your speed at synchronous and your speed at full load torque, at full rated current. And so this is your torque, this is your speed, or this is your speed. So the rated current will always happen here. So this is 100% of your rated current. When during starting, the current or the torque will be much higher, and much higher compared to the rated one. But once it consider or reach steady state, so this should be your speed, and within this range. So that's why I told you the range of your slip is between 2% up to 6%. Okay, because some motor you don't indicate the power rating, you can examine, or you can investigate by you run at full speed, which is synchronous speed. Then when you up at load, when you found that the speed is reduced down to 5% and or up to 10%, so that's your rated current. So you have to stop, or you have to consider that as your full load current speed, and NM, maximum speed. And so maximum speed, or maximum the slip that the motor should be operated at. If you put in more current or more torque, so it will go into the range of your current, rated current is exceeded. Even you have more torque, but rated current is exceeded, so we have over limits in terms of the capability of your motor. So you have to take care of that. Okay.